Hi everyone, welcome back. In this particular video, we will be discussing the problem named union of two arrays. You are given two arrays, A and B, of different sizes. As you can see, the sizes can be N and M. It means they can be of same size, they can be of different size. It is not necessary that both of the arrays will be same. You need to find the resultant array of the union between these two arrays. So just a disclaimer that some of you might have already solved a problem named as merging of two sorted arrays. If you have solved that problem, this problem will feel similar to that, but actually problem is different. Once we will complete the problem statement, you will actually come to know that it is not same as the merging of two sorted arrays. So what you are given is two arrays. Input arrays are not sorted. It is nowhere written it is sorted. So this is the first difference actually. And output is the union, not the merging. Merging is different, union is different of the two arrays and form a single array out of the merged, or you can say the union of both. Elements are not necessarily distinct in the input. In the input, elements can be repeating. However, the note is union of two arrays. What do you mean by that? It can be defined as a set. Set means containing distinct elements, unique elements. Output should contain unique elements irrespective of whether input was containing unique or not. Input can contain duplicates, but output, the union sorted array, or not the sorted one, but the single array right now should be having distinct elements. But if there are repetitions in the input, then only one occurrence of element should be printed in the union. That is again, distinct elements should be there. You should not take multiple occurrences in the output. But one more important point is resultant array, that is the union array, should be in sorted order. This is the second requirement. So input format will be obviously the sizes of both the arrays, and then both the arrays, all the values space separated. So let's say the two arrays are of sizes 5 and 3 respectively. The first array, as you can see, is having values 1, 2, 3, 4, 5. Second array is having values 1, 2, 3. So it is fairly easy to find out the union. That is all the elements set, and it should not have repeated elements. So what you will say? All the elements will be 1, 2, 3, 5 only. 1, 2, 3, 4, 5. That is 1, 2, 3 is common among them. So it will only come once in the output because we need the unique elements. And 4 or 5, although it is only in the first array, still we want it in the output. And also what we are saying is the output should be sorted. That is, output is having 1, 2, 3, 4, 5. Although you might think that it is exactly same or just a little bit difference to merging, but the answer is no, because what can happen is the input arrays can be unsorted. So for that, if you see the second test case where the first array is of 3 size, the second array is of 4 size, first array is having values 5, 8 and 7, second array is having values 1, 7, 8, 5, you can see clearly it is not having a sorted fashion or increasing order. After you will do union of both these arrays, how will the union look like? You will say 1 will come in the union, then next minimum will be 5, next minimum will be 7, next minimum will be 8, and all the other elements are actually repeating. So output should be 1, 5, 7, 8 with unique elements only and in sorted order also. So maybe let's do what? Let's take some more test cases. So let's say the first array is having values 30, then let's say 50, then let's say 40, then let's say 30 again, then let's say maybe 20, then let's say 40, then let's say 60. And the second array, this is let's say array 1, which is having how many elements right now? 0, 1, 2, 3, 4, 5, 6. I'm taking such arrays so that all the test cases will get covered in one example itself. All the scenarios will get covered in one test case itself. So the second array which I'm taking is of different size, but values let's say are 40. Then let's say the next value is 40 again. Next value is again 40. Next value you will say is let's say 10. Next value is let's say maybe 60. Next value is let's say how much? Maybe let's say 70. And next value is let's say 50. So these are the values, or maybe let's not do 50 here. Let's do 50 here so that both the arrays are of different sizes. So as you can see, the first array is having n1, let's say, as a 7 size. Second array n2, rather, instead of taking n and m, I am using n1 and 2 as the size variables. And the second array, as you can see, is of 6 size. First of all, what should be the output? Output should contain union, that is all the elements present from first array as well as second array, but every element should occur only once. It means out of all these elements, the minimum element will be 10. Next minimum will be 20. Next minimum will be 30. Next minimum will be 40. Next minimum will be 50. And the final minimum will be the element, which is 60. So all these elements will come, but in increasing order and only once. So this is the output. But the point is how to find this output. One very brute force approach which might come to your mind is just apply a nested loop. That is, one loop will work on the first array, another loop will work on the second array. I will run an outer loop on the first array, check whether it is present in the second array as well or not. So I will check whether 30 is also present in the second array. And in order to check it, we have to run a loop. So since 30 is not present in the second array, what we will do is we will just put 30 in the output. So initially 30 will get added in the output. Then check 50. Is it present in the second array? No. Or actually, yes. So what we will do is, in order to ensure that 50 does not get inserted again, what we can do is we can mark it -1, or we can mark it something which we should not insert. Some visited is what we can mark. Or maybe for now, we can just not mark this particular value anything. Maybe we can just simply add 50. But when we are about to add it for the second time, then we will check whether it is already added or not. That is, now I will check whether 40 should be added or not. Is 40 present in the output? This time, if you want to check if it is already inserted, then you have to check for the output. So since 40 is not present in the output, insert it. Check for 30. Is it already present in the output? Yes, it is already present in the output. Don't insert it again. So you are running a loop in the output instead of running the loop on the second array. Then you are running for 20. Is it present? No. So insert it. Running the loop for 40. Is it present? Yes. Don't insert it again. Running for 60. Is it present already? No. So insert it. Similarly, do it for the second array. So it will be the outer loop on both the arrays one by one, and inner loop will be on the output array. But still, since there are two loops required, overall time complexity will be quadratic, where the outer loop will be n1 plus n2, and inner loop will also become n1 plus n2, because output size can also be the summation of both if all the elements are distinct. Or you can simply say the time complexity will be quadratic in nature, because you are just simply saying nested loops is what we are doing. Can we do better than nested loops? The answer is yes. There are at least two approaches. Since right now the output order which is expected is a sorted order, both of those approaches which I am about to discuss will be taking same time complexity. But if, let's say, there is a problem which does not require you to print the output in sorted order, then the two approaches, out of those, one approach will be a better approach and one will be a poor than the other one, or you can say worse than the other one. That is, both of them are at least better than the nested loop, but one of them will be even better than the other one if and only if the output is what is expected in any random order, that is not in sorted order. But right now, let's discuss the first approach, which is using sorting plus two pointer, using similar to what you have might done in the merging two sorted arrays. So what I will do is, since we are not sure whether the input arrays are already sorted or not, first thing what we can do is just sort both of them. So after sorting the first array, how will it look like? You will say minimum value is nothing but 20. It will come here. Then 30 will come here. Then one more 30 is there. Then 40 are present two times again. Then there is a value which is 50. And finally, there is a value 60. What about second array? After sorting the second array, it will have 10. Then it will have 43 times. Then it will have 50 and 60. Now, if you want to form a single union array, one pointer you will require on the first array, another pointer on the second array, 0th index, because output is also what is required to be sorted. So now, since both the arrays are sorted, you can just compare whether to take 20 or whether to take 10. So since 10 is smaller, take 10, increment this pointer. Whether to take 20 or whether to take 40, 20 should be taken. Increment the pointer which is pointing on 20, because 20 is taken. Whether to take 30 or 40, 30 should be taken, smaller value. We want increasing order output. But now see very carefully. Again, 30 is coming. Should we take duplicates in the output? The answer is no. We should not say that again insert 30 because 30 is smaller than 40. So before insertion, one check which you have to make extra apart from what you usually do in merging two sorted arrays is that before insertion, check whether that element is already present at the last index, because if there are duplicates, they will come at adjacent indices in the output, because output is also sorted. So just check with the previous index. If previous index exists and it is having the same value, don't insert the node. That is, don't insert 30 again. Simply skip it. Now 40 versus 40. You can actually do what? You can insert 40 one time and just increment both the pointers. Why? Because again, 40 will not get inserted duplicate times. Again, there is a 40 versus 40. So again, you can say don't insert both of them this time, because this 40 is same as this one. This 40 is also same as the last index. So just increment both the pointers, or you can increment one pointer at a time. Now 40 versus 50, again 140 is the minimum. The second array is 40, which is still the same value. Don't insert duplicates, simply discard it. Now is that point you will compare 50 with 50. Insert 50, increment both the pointers. 60 versus 60, insert 60, increment both the pointers. As soon as the first array finishes, you can just simply run a loop on the second array and do the same job. Or if the second array gets finished, you can run the loop on the first array and do the same job. So what will be the time complexity associated with it? You might say it is n1 plus n2, but no, you are wrong. Because when it comes to merging two sorted arrays, we do order of n1 plus n2 time, given that the two arrays in the input are already sorted. But in this question, the two arrays were not sorted. We first sorted both the arrays and then applied two pointers. So sorting both the arrays will require n1 log n1 plus n2 log n2 time. And then to merge both of these arrays into a single array by discarding duplicates, it will take n1 plus n2 time, because output can be worst case having all the elements present in first array plus second array, that is n1 plus n2 in worst scenario. So since we are just applying two pointers, one pointer running n1 times, second pointer running n2 times, that's why it is n1 plus n2 only. So overall time complexity, you can say, will go in worst case as n log n, where n you can represent as capital N, which is the overall size of the output, due to the fact that we need output to be sorted. But there is a even better algorithm which will work obviously for this particular scenario where we have to give the output in sorted order, but which it will work even better if we don't want the output to be sorted. So what is that third approach? That third approach is focusing on the part that we want unique values. And what is such a data structure which can give us unique values? Such a data structure is known as set data structure. We actually don't require map here, because we don't want to store value for a key. That is, we won't store how many times a particular element is there. We don't care whether 40 is present 3 times or 4 times or 5 times. We don't care. We only need to check whether an element is already part of the output or not. So what we will do is, we will say that given the first array, given the second array, run a loop on the first array, insert all the elements in the set. Then run a loop on the second array and insert all the elements in the same set. And set will maintain uniqueness over the values. So I will run a loop, insert 30. Since 30 is not present, it will get inserted for the first time. Since 50 is not present, it will get inserted for the first time. Since 40 is not present, it will get inserted for the first time. 30 is not present. Actually, 30 is present, so don't insert it. Automatically, set will ignore the insertion. It will just skip the insertion because the element is already there. In a set data structure, a hash set, you will not have duplicate keys. That is a property of set. Then 20 will get inserted because 20 is not inserted yet. Then 40 will get inserted. No, because it is already there. 60, yes, it will get inserted because it is not there till now. 40 will not get inserted because it is already there, already there, already there. What about 10? It is not there. Get inserted. 60 is already there, irrespective of whether it was inserted by the first array or by the second array. We don't care. It is there in the set. Don't insert it again. 50 is already there, don't insert it again. So as you can see, the set data structure will have all the unique values. However, since in this current question, what we require is a sorted output. Now there are two things which you can do. Either first put all these set values into a list or into an array, whatever is the output expected return type, and then just sort that array and return it. That is, sort that list after converting the set into a list and return the sorted list. Or what you can do is, instead of making a hash set, instead of making a set which is unordered, hash set are usually unordered. That is, they can have keys in any order. It is not necessary it will have the keys in the sorted order. What you can do is, you can go with a sorted hash set. Actually, it is not known as a hash set in that case. It will be a sorted set, or you can say in some languages it is known as a tree set, because internally it is using a binary search tree, a variation of it, or you can say a self-balancing binary search tree. So the point is, either if you don't know about such a set, if it does not exist in your language, maybe tree set or ordered set does not exist, just go with the normal set to list conversion and then sort that list. Or you can actually go ahead with the direct sorted set itself and then just convert that sorted set into a list. Now no need to sort it again because it is already sorted. In both of these scenarios, considering the output, that is the set size, to be n, capital N, which can be worst case n1 plus n2, converting a set into a list will take n time only, but then sorting that list will take n log n. Versus if you are creating a sorted set itself, inserting elements in a sorted set will take log n time, where n is the size of the set. And inserting n such elements in that sorted set will take n log n time. And then if you are just putting all those elements from sorted set into a list, it will take n time. So irrespective of whether you do this, it is n plus log n, or whether you do this, it is n log n plus n. The overall time complexity will remain same as the previous approach, which is n log n only. So the point is, this algorithm will have, or this approach will have the same time complexity due to the fact that we want output to be in sorted order. If output was not expected to be in sorted order, then we can just skip this final step. That is, just print all these elements in the order which hash set is giving to us. And since hash set will get insertions in constant time average case, n insertions will be only n. That is, if the question was not expecting us the sorted order, it will take only linear time, not n log n time. In that scenario, approach 3 will be better than approach 2. But right now, if you want to go with approach 2, it is still fine because it is still taking the same time. What about space complexity? If we are talking about the approach 2, or maybe let's start with the approach 1 directly, that is the nested loop. In this, space complexity will be constant. That is, you will not require any extra data structure as such. You just have two input arrays and one output array. We never usually include input and output into extra space. Right now, we are talking about extra space or auxiliary data structures. So for the first brute force solution, it is constant extra space. For the second sorting plus two pointer solution, sometimes what happens is the sorting which you are doing, if it is a merge sort or if it is a quick sort, it might take n time or actually n space due to the recursion or due to maybe the merging requiring you to create a new array. So sorting, if it is going to take n space, you can say space complexity will be linear. That is order of n. And what about the third approach? Again, since you are clearly seeing that we are making a set data structure, or you can say a sorted set data structure, which is extra, which is auxiliary data structure, not given in the input, not given in the output. So it will again take linear space only. That is, the space complexity will be order of n, where n is capital N. That is the sum of both the individual arrays, n1 plus n2. In worst case, output can also have all the elements. So with that, we are done with the three approaches. However, the instruction manual which I am going to write will be based on the third approach, because right now we are practicing the problems based on set data structure. So what we are going to do is we are going to say that create a sorted set, and in the bracket I am writing that sorted set might be named as a tree set in your language. Like in Java, it is known as tree set. In C++, it is only known as set. If you just create a set variable, it will be a sorted set, not a unordered set. So create a sorted set of integers. Do what? Run a for each loop probably. No need to run an index based loop. You just have to get values of the arrays. So run a for each loop over both arrays and insert them into the set. Insert all the values in the set. Once we have inserted all the values, what we have to do is copy the elements, from the sorted set into into a list, so that we can return that list. So final step will be just returning that list. So it will be just 4 or 5 lines of code, not that much, provided that there is a inbuilt library which you can use to use the sorted set. If it is not, then maybe you can just go with the hash set, or maybe you can go with the sorting plus two pointer. So we will be writing the code in Java programming language. And how to create a sorted set in Java? It is tree set with T capital, S capital. The type should be of integers. That is, keys will be integers because input is of integer arrays or the lists. So I will create a set of sorted nature. That is a binary search tree, a self-balancing binary search tree. Initially, it will be empty, but how we will populate it is by running a loop, a for each loop, probably on both the arrays, on both the lists. That is the array list maybe. So I will run a loop over the first array on the values by using this syntax. That is, I will get one element at a time from the array. Since arrays of integers, you can write int here, it will work. Or if you just directly want to write integer, it will still work again. But the point is, it will not give you the indices 0, 1, 2, 3 up till n minus 1. It will rather give you the values directly. That is, if this is the array, the element variable will not iterate over 0, 1, 2. Internally, it will iterate, but element variable will be storing 30, 50, 40, 30, and so on. One by one, you will be getting the values. And you have to just insert them into the set. That is set dot add will be the function to insert the element. So you don't have to care whether the element is already there in the set or not. Add operation will automatically take care of the insertions, not for duplicates. That is, duplicates, even if you are trying to insert, it will not get inserted because that is a property of set. Same thing you have to do for the second array. So I'm just running the loop. I'm just replacing A with B. That is the second list and inserting all the elements from second array as well. Now that we have both the arrays elements into the set, they are first of all unique, that is not duplicate because of the property. Second thing, again, because of the tree set property, sorted set property, all the values will be in increasing order by default. And what you can just do is pop all the elements or run a loop over the set and insert them in a list, which you have to return. So I will create a list, which will be initially empty. And how to create a list? On the left hand side, because we want to return a list, left hand side should be a list. List is actually an interface in Java. But to create an object of list, to instantiate a list, you can't do it like list is equals to new list. This is not a correct syntax. You can't create object of interfaces. You will have to create an object of something implementing list. So you can do maybe a linked list, you can do maybe a array list, you can do vectors also. But the easiest way or the most famous way is using array list. So you can implement the list using a array list. And initially it will be having zero elements, zero size list will be there. What we will do is we will populate it with all the elements in the set. So this time the third for each loop, rather working on the first A list or the B list, but instead of them, it will now work on the set. That is copy elements from the sorted set into the list. That is, I will say in the array, the output array, just insert at the last index. That is add operation again, the current element. And as soon as we are done it, we will just return that list. So we will just say return this particular list. That is the ARR. You can name it anything. So let's see if it is going to work fine or not. Let's wait for the sample output to be correct. Then only we will submit it. As you can see, it is working for this corner scenario where the input also was sorted. But even if input is not sorted, still it will work. And as you can see, input is having duplicate elements. That is, one is present in both the arrays. Still, it is only coming one times in the output. That to sorted, it means the logic is working fine. Let's do what? Let's submit it and confirm whether it will work for all test cases or not. Right now, it is showing a previous submission. Let's wait for the current submission to show up. So it takes some time to show up the submission, but it will get auto refresh. As you can see, now it is getting accepted. And what is the time complexity for this? Creating a tree set does not involve any time complexity, but inserting the elements in that tree set will require login for each insertion in average case or even in worst case. And if we are doing n such insertions, where capital N is nothing but n1 plus n2, that is the first array size plus second array size, it will be n1 plus n2 times log n1 plus n2, or you can simply say capital N times log capital N, n log n. And then what you are just putting is running a loop over the set, which you can do in linear time, that is order of n time, and put all the elements in an array list. So that is a linear operation. So n log n plus n overall time will be n log n. We always take the biggest power of n or the biggest term. What about space complexity? Since right now we are using a set data structure, a extra data structure, auxiliary data structure, which can contain all the n elements, n1 plus n2, space complexity will be linear. So time is n log n, space is n. What you can do is you can try to solve some problems related to this, maybe merging of two arrays, intersection of two arrays. Problem might be union of two arrays without the sorted part, without output needs to be sorted. For that, you will actually have to do it with hash set if you want to do it with the most optimized way. So having said that, let's keep this video till this point. We will meet in a new video with a new problem. Till then, bye bye, take care.